This is part 4 of solving quadratic equations by completing the square, and we do the following 2 problems on this video. This is part 4 of completing the square. We're going to continue solving quadratic equations, but in this video we're going to do ones where the coefficient of x squared is not 1, as in this example, 2x squared plus 4x minus 1 equals 0. Since this is an equation, what could we do to make that coefficient 1? Well, we could divide by the coefficient of x squared. So if we divide both sides by 2, basically that just means we're dividing all terms on both sides of the equation by 2. Now if this was not an equation, you couldn't do this, right? This is one of the properties of equations. So that now gives us x squared plus, now 14 over 2 is 7 halves, so we could write 7 halves. And what we're going to do is leave a space for completing the square. And we're going to put that negative 1 half, add 1 half to both sides, so we have 1 half on the other side of the equation. And remember, I am going to add something to both sides of the equation, so I need to put a little blank over here. I'm going to move this over a little bit. Here we go. Okay. Now from here, everything else is the same that we've done on parts 2 and 3 when we were solving equations. So what do? We go down here and decide what would go in the parentheses if it was going to be a perfect square of what was up here. Well, to get the x squared, it's an x. See, if it was 2x squared, that wouldn't have worked, right? Because x times x is x squared. So this will have to be an x, and this is a plus sign in front of the 7, and then we have to take half of that coefficient. So half of 7, remember, since it's an odd number, we'll just write that as 7 halves. So what gets added up here? Well, 7 halves squared. 7 halves times 7 halves is 49 fourths. And we add that on both sides of the equation. All right, now I need to simplify the right-hand side, so I need to have a common denominator, and that would be fourths. So let's see, how about if I just multiply this first fraction 1 half by 2 over 2. Now I'm going to have fourths. So I will have 2 fourths plus 49 fourths. That'll give you 51 fourths. So we do have more fractions, but, at least we're able to work through the problem. So at this point, I can take the square root of both sides using the square root property, so that we have the square root of the square root is x plus 7 halves. And remember, you must put plus or minus in front of what this is going to be. So I've got the square root of 51 over 4. So the square root of 51, that can't be simplified. 51 is 3 times 17, so I still have the square root of 51. But the square root of 4 is 2. And at least we've got a fraction with the same denominator on both sides. So we're getting close. We're going to subtract 7 halves from both sides. So I have negative 7 halves plus or minus square root of 51 over 2. And we could write that as negative 7 plus or minus square root of 51 all over 2, since it has a common denominator. And I'm just going to write my solutions. There's 2 different solutions. Negative 7 plus square root of 51 all over 2. Negative 7 minus square root of 51 all over 2. And as long as we didn't make any mistakes, that's the hard thing. It's easy to make mistakes. Those should be our 2 answers, solutions. You could always check. It's easier to redo the problem usually than actually plug that in for x and check. Okay, ready for another problem? Just remind yourself this was the original problem. Oops. It was 2x squared plus 14x minus 1. So if you did check it, that's what you're going to be checking it in. And then we got these solutions. Negative 7 plus square root of 51 over 2, and negative 7 minus square root of 51 over 2. All right, here's our next problem. If you think you got it, go ahead and put the video on pause and try this one on your own first. All right, here we go. Well, we don't have an x squared, we have a 9x squared term. At least we have the x squared and x term on the left side and the constant on the right, so we don't have to worry about that part, but we do need to divide both sides of the equation by 9 so that we just have the x squared term. X squared minus, and oh, this is nice, we've got 36/9. That's just 36 divided by 9, or 4x. That's going to be not so bad to complete the square. And on the right hand side we have -40/9. Whatever we add on the left side we're going to also have to write on the right side. Okay, so let's complete the square. Now that this is an x squared, we'll have an x, that's a minus, and we do half of the coefficient. So since the coefficient of x, we've got 4, half of that's going to be 2, and 2 squared is what gets added to both sides. So I'm adding 4 to both sides. Everybody all right with that? Instead of writing 4, how about I write that with a common denominator of 9? So 4 is the same thing as 36 over 9. Remember, you can get that by multiplying the top and bottom by 9. So this gives me, and the reason I did this is to save a little space, I've got -40 plus 36 all over 9, so that's -4/9. Okay. All right, now we have something squared equals -4/9, so we can use the square root property, taking the square root of both sides. So if x minus 2 equals, and don't forget, plus or minus. Right, now, anytime you're taking the square root of a minus something, a negative number, remember that's going to be a complex number. So it's going to be the square root of 4/9 I, correct? So what's this is going to be the square root of 4/9. That's the square root of the top, which is 2, and the square root of the bottom, which is 3i. Or if you want, you could write that as 2i over 3. So x will be 2 plus or minus 2/3 I. Right, this gives you two solutions. And this is writing the solutions in the form a plus bi. But you could also write the solutions with a common denominator. And if you did that, you would multiply this 2 by 3 over 3. And that would be 6 plus 2i all over 3. If you had written it with a common denominator, convince yourself that's the same thing. 6/3 plus 2/3 I, right? 6/3, of course, is 2. And the other solution would be 6 minus 2i all over 3. All right, so make sure you realize that, when you're looking at the answer, let's say you're looking in a textbook at some answer, depends on if they're going to write the answer in the form a plus bi or just write it as single fractions all over a common denominator. And again, to check this, you would have to plug this in for x into the original equation, which was way up here. 9x squared minus 36x equals -40, and it would take you a little time to do that. But there we are.